Alright, so we have this water is being poured into an inverted cone of radius 6 centimeter, right, and a height of 10 centimeter at a rate of 3 cm cube per second. So meaning that when you see the 3 cm cube per second, is actually the rate of change. So this is your dV dt. Okay, so the very first part is to ask us to show that the volume of the water, which is right here, right, is given as such, is given as this, right? So V is equal to 3 pi x cube over 25. Okay, so how do we actually do this question? Very simple. This one you will need to go back to the EMAT similarity and congruency, right? Because if you look at the, if let's just say I draw the 2D shape, so for example, right, okay, this is the shape of the cone. This is the so-called container, but the water only fill up to here only. So you can see there's a similar triangle. Okay, so let's take a look at the big triangle first. So it's 6, and this is 10, right? Then what about the water? The water has a so-called this, right? X. Okay, so I want to determine what is the so-called radius of this thing. So I simply just use the similarity. So the scale factor, if you still remember. So this thing is 6 over, let's call this R. Let's call this R. So 6 over R, right, is equal to 10. So 10 is this, right, over X. So 10 over X. Okay, so I want to make X the subject. So I do a bit of cross multiply. So 1 and 2. So I just put 6x is equal to 10R. Okay, sorry, I want to make R the subject, not X the subject. I make R the subject means I'll get R equal to 6 over 10x. Okay, so with this, right, I will need to, okay, I want to show the volume, right? Okay, very simple. Now, you just need to understand that the volume of a cone, so for example, this is the water, right, which is in the cone shape. The volume of the cone is 1/3 pi R square, so-called height. So what is the R? So R is this, right? Then height I know is in terms of X, which is this. Okay, so I just simply put, so for example, right, volume of this is 1/3 pi R square. So what is R square? So of course, if you look at this, right, just now I use the similarity of triangle, I get R. So it's 6 over 10x bracket square. Then after that, you times the height, so x, so it's equal to, let me just do a bit of calculation. 6 over 10 times 6 over 10. Okay, so I times 1/3. So this will give you 3 over 25. Pi x squared times x is x cubed. So in this case, I already showed already. So the volume is given as such. Okay, so for part B, find the rate of change of x, right? Okay, let me just write down. Okay, part B, find the rate of change of x dx dt when the radius of the water, radius of the water, I just put R, is equal to 3 centimeter. Okay, so to do this question, very simple. That's where you need to always write down the chain rule. So dy dt, sorry, not dy dt, dv dt is equal to dv dx multiplied by dx dt. So if you look at the chain rule, we are given this, right? dv dt we are given. Okay, dv dx, not say we are not given, actually we can find, because there's always a reason why they ask us for the first part. It's actually to help us to do the dv dx. So this one is from here. Okay, what we are asked to determine is actually the dx dt. Okay, so first, how do we actually do this? We always want to sub in first, right? So for example, we know that dv dt is 3 cm cube per second. Okay, what about the dv dx? Very simple. You just need to differentiate, right? Differentiate v with respect to x. So I do the dv dx first. So dv dx, right, is equal to, okay, power bring down. So it's 9 over 25 pi x squared. So I get the dv dx already. So 9 over 25 pi x squared. Okay, so they say that the radius of water is 3, right? Okay, so let's just remember one thing is that radius and x is different. Radius, if you want to look at the relationship between radius and your x, it's actually given as such, meaning that the radius is about 6 over 10 times of your x. So let me just write here. So radius, right? Okay, radius is 3, so radius is equal to 6 over 10x. So what is our x? Because all my expression is in terms of x. So I need to determine, I need to determine what is my x value. Okay, so I just use 3 divided by 6 over 10. So this will give you 5. So my x is 5. Sorry. Okay, my x is 5. Okay, with this, I can actually determine my dx dt, right? Okay, because why? Because first, I got this already, 3. Okay, so what I want to do now is actually to sub in the x equal to 5 right into here. So x square, right? So means is 5 square, 25. So it's equal to 9 over 25 pi. So x square is 25. So this is 25. Okay, so with this, right, I can actually determine what is your dx dt. So 3 divide by this whole thing right here. So 3 divide by 9 over 25 times 25 pi 25, right? So it's equal to 9 pi. So this will give you dx dt. Because why? Because 25 and 25 cancel out. So that's why I put 9 pi. So 3 divide by 9 pi. So your dx dt, which is not a very nice number, is equal to 0.106 centimeter per second. So that is how you do this question.